One of the things that is really interesting with this INS is that it will always output standard data telegrams of its Ethernet and serial port. This is the very same port that you can use through the case study number 2, the advanced integration. To access this feed, I will show you in the web interface, but you will basically connect with your own means to this feed. So I type the IP address of this unit, and it's always displayed on the port 8110. And you will see what we call the repeater telegram. So this telegram contains all the data this unit is producing, and like the AXBlue standard bin protocol is displaying also all the input sensor rebroadcast as an output. This is also where you can send control command and receive acknowledge commands of your data. There is 2 methods to do so. The first method will be to recover it via the serial repeater line. The serial repeater line is available as an output to wire on this connector, and connecting at the time of boot of the unit to the communication port with the 56 kilobaud 8.2 as a parity, you will read the IP address of the unit currently configured. The alternate method is to use the network, so the Ethernet line, to use a scanner, a Wireshark kind of software, and if you have chance, if you're in a close-by IP range, you can get the MAC address of the unit, which finishes by the serial number, like the IP address at the time of the factory, and you can get its IP address through its MAC address. Like we've seen in the previous videos, there's a great deal of sensors you can interface to that unit. Let me give you a few tips on how to choose them and how they will work while used together. As you remember, we have 3 families of sensors: the positioning sensors, the speed sensors, and the time sensors. So positioning sensor, while integrated with your INS, will result as a bound performance value. You will get 3 times better than the positioning sensor accuracy outputted from your inertial solution. The speed sensor will bound the performance to 1% of the travel distance. That's why, for example, when coupled to a DVL, you reach 1% of a travel distance performance. But if you use both position and speed sensor together, you get extra benefits. On overall performance, while the 2 sensors are available to the unit, you will get the best of both solutions. And while one or the other gets not usable, for example, in the case of an interruption of data or non-availability on sensor, the algorithm will give you effect on position from speed, and from speed will effect on position. It will also somehow, with your operational trajectory, be able to be optimized. Which sensor to use? The best thing I think to consider is to use as much sensors as you have available to you, available on your vehicle. The more accurate the sensor will be, the better it will be for the resulting solution of position and orientation of the unit. The more raw the sensor is, the better it is. Our algorithm will work very much better with realistic raw data from sensors. Typically, we'd rather have a 1 Hz GNSS solution than a 10 Hz pre-filtered GNSS solution. Telegram, if you can configure them with a standard deviation information as an input to our unit, will use those information to enhance even better the navigation solution. And keep in mind also of this advanced filtering page I introduced you in the previous videos. At last, let's speak about time. time will be important, especially in autonomous vehicle. If you input a time feed together with your sensors, it will help to make and compute better result data, better solution as an output to your data. Actually, like external sensors, we have inside this unit also what we could consider as algorithm sensors. They will come in the shape of two features. The first feature are the ZUP mode. ZUP mode stands for zero velocity update. You can configure, we've seen that through the navigation page at different settings. We chose in the previous show to let them by default because we were in a OEM integration standard case study. But we could choose to use those ZUP mode to improve our applicative scenario. For example, if I'm on land before deploying my vehicle on sea, at sea, for example, I could use a ZUP mode to enhance the performance of the unit prior to a test at sea. Likewise, I have other algorithm sensors, which I would say is the manual position. The manual position fix is a feature that allows you through the web interface control or through control command with the unit to send a position information to the unit. It will allow the unit, for example, to reduce its drift rate should you be in a long-term autonomous application, but it could also be used to enhance its performance. Thanks for watching this series of hands-on video. I hope you have some great pleasure watching them as much as we had doing them here in the studio. As a small reminder, do not hesitate to reach out to us. Do not hesitate to reach out to iXblue support team 24/7. We're always happy to take your technical questions if you want to react to those videos as well, or if you'd like to have more details and specifics we explain to you. Do not hesitate also to reach your usual contact at iXblue. We are always here to speak with you. Thank you for watching.